All right, so hopefully you watched the derivatives day 2 video. Otherwise, there's no chance you're going to know how to do this worksheet. There's really two different things that you focused on in that video. And the two different things were, are you talking about a secant line or are you talking about a tangent line? The key phrases here are always looking for an average because a secant line requires 2 points. A tangent line is talking about what happens when the graph is just intersected at 1 point. And so that's going to be at one instant, we say. So we call it instantaneous. And so when you see those words, those are some of your key phrases. So if I have a graph here, a tangent line is going to touch at 1 point and just scoot right past. And so I'd be able to find information about just that one instant. Here with the secant line, you're going to have 2 points going on. And so it slices through. If you think back to geometry, even tangent just touches and a secant slices. And so here you have 2 points. So you're going to be looking for the average of those two. Here you have just 1 point. You can't find the average of that. Here we use something called the difference quotient. And here we use something called derivative to find information about that 1 point and the slope of the line of that 1 point, because we're always interested in the slope of that line. The difference quotient is the one where we're going to take f of x plus h minus the original function all over h. So this one's going to have an h in the answer. Anything that's asking about a difference quotient will have an h in the answer. Derivative, on the other hand, which has a whole lot of ways of writing it. It might say y prime, it might say f prime x, they might write it as dy dx. Those all mean derivative. And here, you're really doing the same thing, except you're finding the limit of that as h goes to 0. So this one is going to have no h in the answer because you're letting that h go to 0, like we talked about limits. So as h goes to 0, you basically plug into 0 for h. So if you watch the video, there was two boxes that you wanted to focus on. Okay, so then when you get to each of these things on the worksheet, you have to decide, what am I doing? And you can see here that the top half and the bottom half are the same. So I'm just going to kind of walk you through the top, and then hopefully that will help you get through the bottom on your own. So the first thing that happens is it's giving me a function, and just because I won't have enough room on there, the original function is 2x squared minus 5x plus 8. It's going to ask me questions about the secant line, so I'm going to need to do the difference quotient. So I'm going to have to go through this process right here. So that can be a little tricky because f of x plus h means taking all of the x's in this whole thing and plugging in an x plus h. So that, what I just wrote out, is the f of x plus h part. Then I have to take away this original function, which is 2x squared minus 5x plus 8. And I'm putting those brackets around there to remind me later that that negative is going to affect all of them. So this whole thing is my f of x plus h. This whole thing is my f of x. And then according to that difference quotient, the entire thing has to be over an h. So now you have to use your algebra skills because you're going to need to do x plus h times itself because that's a foiling problem right there. Here I'll distribute my negative 5 to the x and the h. I'll have this 8. This negative will distribute, so these will all become opposite signs from what they were. But this part I still have to FOIL out, and that'll turn into an x squared plus 2xh plus h squared, and then I still have to distribute this 2 out in front. So right now I'm just working on the top of this. So I finally get, when I distribute this 2x squared plus 4xh plus 2h squared from distributing that, and then the rest of what I had. Minus 5x minus 5h plus 8 minus 2x squared plus 5x minus 8 all over h. So at this point, I'm going to be doing like I did on derivative day one. I'm going to be looking to cancel stuff out, and I'll know that I did it right if everything cancels except for the parts that have an h. So for example, this is a 2x squared. It doesn't have an h. Somewhere in here, there better be a negative 2x squared, which there is. Those cancel. 4xh is fine. 2h squared has an h. Negative 5x doesn't, so I'm looking for a positive 5x, and those cancel. Minus 5h is fine. Positive 8 does not have an h, so I'm happy to see there's a negative 8 as well. Because if you are correct at this point so far, it's a good way to check your work. You should have an h in every term that you have left. Then what I do is I pull that h out in front, so the top becomes a h out in front of 4x plus 2h, because that was squared, so I still have one, minus 5 all over h. That's gone. So my difference quotient answer is going to be 4x plus 2h minus 5, keeping in mind that h is representing the distance between whatever two x values are given. So you're trying to be working with 2 points on the graph. They're each going to have a different x value, and so the space between them is going to be your h. The derivative here, the f prime of x for this problem, is really easy. I don't have to do any extra work. I just have to remember that h is going to go to 0, so then my derivative would be just the 4x minus 5 part. So that's how I would find the slope of a line at any x point. So if I have the point here, the tangent line obviously has a very different slope than if I have the point over here. But at each point along this curve, I can plug in the x value to this little function I just found, and it'll tell me what the slope of the line is tangent at that specific spot. So if this is at an x value of 2, I would plug a 2 in here. 8 minus 5 is 3. So then I would know the slope of this line would be a 3. And if this is at negative 1, then I would plug in a negative 1, and I would find out that the slope of the tangent line at that spot is a negative 9. So I've got all my work done, and now I can go in order and just kind of address each question, but I have to think a little bit about what each one's asking. This is asking for average rate of change. Anything average requires 2 points, and so the average rate of change between any 2 points on the curve is going to be my difference quotient. And since it didn't give me any numbers to plug in, it's looking for just the difference quotient. So I go back to my work, and I would put in 4x plus 2h minus 5, because the average rate of change between any 2 points is asking for the difference quotient. How about the average rate of change between these two? Okay, so now I'm going to actually use this. So I'm starting at an x of 2, so I'm going to say 4 times 2 plus 2. Now keep in mind that h is the space between them, so from 2 to 6 would give me an h value of 4. So I'm plugging that in here, and then minus 5. So that's going to be 8 plus 8, which is 16, minus 5. So the average rate of change from 2 to 6 is going to be an 11. Which means if I drew this graph, and this graph's a parabola, and I went from x is 2 to x is 6, the line passing through those 2 points would have a slope of 11. All right, keyword here, instantaneous rate of change at x equals 2. Well, instantaneous indicates that you're talking about one moment or 1 point, so I need to use my derivative formula, and so this one's going to be the one without the h. So what this is asking is, what's the derivative value when x is 2? So I go back to my derivative formula that I had worked out here, which is just this one, except without the h part. So 4x minus 5 is my derivative, and I'm plugging in a 2. So that's 8 minus 5, which is a 3. Okay, so that's saying if I had a line that was just tangent right here, what would the slope of that be? And that would be 3 instead of this one, which was 11, because this one had to also go through this second point. So that ended up being much steeper than the one that just grazes past at x equals 2. Okay, slope of the tangent line at 2 is kind of just a tricky question because these two mean the same thing. That's the key thing in calculus is figure out what are they asking you. Here they're asking you for instantaneous rate of change. Here they're asking for the slope of the tangent line. Those are the same exact question mathematically, so my answer is going to be 3 again. Okay, the derivative is asking me for that derivative function, and so I would have f prime x, which is just the way we write it, or you might write dy dx. Those are the same thing, but the function itself is 4x minus 5. That's what they're looking for. Okay, what is the difference quotient? Well, that's the same as what we had up here in question 1. The average rate of change between 2 points is the same as the difference quotient, just like instantaneous rate of change is the same as the slope, which is the same as the derivative. So we just kind of want to group those together. So we already answered this question. They're just testing our vocabulary and understanding of what's what. So now this is asking for the slope of a secant line, and a secant line requires 2 points. So you can either do this old school and use your slope form, but then that means I have to plug a 3 and a 7 into each of these and then figure out the y values. So instead, I'm just going to go back and use my difference quotient again. And so that's going to allow me to not have to go plug in, find my y's. I can just go and say, okay, my difference quotient was this 4x, and I'm starting at an x of 3 plus 2h, h being the spread from here to here. So in this case, h would be 4 because from 3 to 7 is 4, and then minus 5. So this one's giving me a way to find the slope without having to do the slope formula, because that would make me plug in the 3 to find a y, plug in the 7 to find a y, and then do slope formula. So I'm kind of going around that by using my difference quotient instead. So 12 plus 8 is 20, minus 5, so 15. Okay. Back to my picture, because this was from an x of 2 to 6, 3 to 7 would end up being an even steeper line, which is why this slope is 15 compared to 11 and 3, the other ones we had before. Because as you follow this curve, it gets steeper and steeper, so the slope lines go with it. Okay, average velocity. Anything that says average falls into my category of secant, and I use my difference quotient. So I think, okay, this is a difference quotient problem. So I'm going to use that again. 4 times my first x of 2 plus 2 times h. And in this case, from 2 to 7, my h would be a 5, and then minus 5 here. So that's 16 plus 10 minus 5. So I have 26 minus 5. So this one's 19. But again, going back to my picture, which is getting a little messy, if I went from my x of 2 all the way up to my 7, now that line would be even steeper than all these others, which is why it has a steeper slope or higher value. And then don't let this freak you out. All this is asking is the same as this, which is asking for the same as the derivative, which we already answered. We already answered the derivative question here. And so our derivative is 4x minus 5. And it doesn't say what's the derivative at 2 or 3, so we don't even have a number to plug in. So I'm hoping that if you kind of walked through this with me and you watch the video, then you can watch these key words and then decide when I'm using each of these, average rate of change, that's going to be difference quotient, instantaneous rate of change, slope of the tangent line, these only give me 1 point to work with, so these will be derivative. Derivative, probably going to be the derivative. Difference quotient, probably going to be the difference quotient. This would be the thing you want to do first, same as I did. Take your difference quotient and go through the process of finding your actual difference quotient. Once you get it, write your derivative, and the only thing you have to do there is take your difference quotient and ignore the h part. So use all that to get through there. Just practice the language. The math is not that hard. It's basically doing the slope formula. So hopefully going through that top will help you get through the bottom, and then you can also look back at the video for more help. Hope that helps you guys. Otherwise, I'll see you in the WebEx room if you need some more help. Bye.